We are discussing relative maxima and minima. Some of you may say maximums and minimums. Maxima is just the plural of maximum, and minima is the plural of minimum. Okay, so we're discussing the minimums and maximums of the graph. Okay, maxes and mins is also something you will hear me say in class. Maxes and mins. Okay. All right, so looking at this graph, we want to decide what are some relative maxes and mins from the graph. Now, relative is describing relative to the space around the point, is it a maximum? This point right here, negative 3, 2, looks like it would be a maximum, correct? But if I look at the whole function, there's definitely some of the function that goes higher than it, right? If I were to draw a line all the way across, this part of the function is higher than it. But this is a relative maximum because it is a maximum around the area it's at. So another relative maximum would be this point over here. Minimums, we would have a relative minimum right here. And another relative minimum right here. Okay? So when we're talking about relative maxima and minima, we are talking about the maxima and minima that are maximum or minimum around their kind of area, their domain, right? Their spot on the graph. Okay. All right. So for example 1, we are to mark and label all the maximum and minimum points on the graph. I am going to do my maximum points in green and my minimum points in red. So maximum points, I'm going to write maxima, there we are. And my minima are going to be in red. So my maxima, well, let's look over here. You can see that this is kind of a turning point, right? It's always going to be those turning points on the graph. This right here is a maxima. It's a maximum. This right here is a maximum. And this right here is a maximum. So this point, this first one I highlighted, is at negative 5, negative 1. This one over here is at 1, 5. And this one over here is at 5, 2. All right, our minimum points are going to be here and here. These two are not because the graph continues off the screen, so we do not know if the graph turns around right there. So this point right here is going to be 0, negative 4. And this point over here is 3, negative 3. So we have 3 maximum points and 2 minimum points. I apologize. All right. That is example 1. Example 2, we're going to consider the polynomial function g of x equals negative 0.5x to the fourth plus 3x squared plus 2. How can you use a table to identify the maximums and minimums of a function? So this is the table that gives us some points on our graph, right? We could plug in more if we wanted to, but we're just going to deal with those for now. Okay. A table, as you will see, and if you've watched the increasing and decreasing video, you will notice that it's very similar with maximums and minimums to be exact when you're doing it from a table. Okay. All right. So if I'm graphing these points, I have negative 3, negative 11.5. Oh, I did not leave enough room on this graph. Negative 3, negative 11.5 is way down there. We're going to change our intervals over here. We're going to go negative 1, negative 2, negative 3, etc. Okay? So that means this is going to be negative 8, this will be negative 10. Okay, negative 3, negative 11.5 is about right here. This is going to be 1, 2, 3. This is 8, and that's 10. Okay. Negative 2, 6 is at negative 2, 6 right here. You have 6 right there. Negative 1, 4.5 is going to be right there. 0, 2 is going to be right there. We have 1, 4.5. We have 2, 6. And we have 3, negative 11.5 right down there. So our graph looks something like this. So we have a few turning points, as you can see. Now, this graph, sorry, I'm drawing this a little weird. This graph doesn't necessarily turn at these points right here. All right. Oh my gosh. I am struggling to draw this. There we are. Now, it would be hard to know this just drawing it. All right, there we are. But this graph continues up a little bit right here and here. So all we can really determine is that there is a maximum between -2 and 4. Sorry, negative 1 and -2. I apologize. And that there's a maximum between 1 and 2. We can't really say it exactly. We do know that there is a minimum right at 0, 2. So that's all we can get from it exactly, is there's a minimum right at 0, 2. Tables are not the best methods to get maximums and minimums from a graph, right? So let's go to a graph, example 3, identify and mark the minimum points on the graph. So looking at this one, as we come down, and we have a turning point. So that means we've got something there. Here we go up, we turn around. That one, though, we're going from increasing to decreasing, so that is a maximum. Coming down, we keep going down, 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 then we turn to go up. So going from decreasing to increasing, we have a minimum. So our minimum points are -3, 4, and 5, -6.